All right, so 1.6, other types of equations. By the way, just a couple administrative things. I'm thinking about when I want to schedule the first test. I'm pretty sure we just have 1.6 and 1.7 left before we can do the first test. Here's the dilemma I have. So I always like to schedule the test around the time when the last homework is due. The problem is that the homework is kind of stretched out all through next week. And if I put the test off that far, you'll go into the test a little bit cold. So I don't like to usually put the test off that far from when I cover the last piece. So the only thing I'm thinking is so the last homework is due not this Sunday, but the Sunday after, correct? Most of you probably aren't even online yet, are you? You might want to get there pretty soon. But anyway, just trying to think if we would want to do a Thursday, Friday test next week, or if you want to do like, probably be a Monday, Tuesday test the week after. And if we did a Monday, Tuesday test, we'd have a review day on Friday, and you'd have all weekend to study. Yeah. All right, so let's plan on the Monday, Tuesday test. That would be, let me check my calendar. So that'd be the 23rd, the 24th. Hey, listen to me very carefully. Once we hit the end of the material, once we hit 1-7, we're moving on, okay? But the stuff I'm moving on with won't be until the Chapter 2 test. You got to stay fresh with your Chapter 1 materials, okay? So even though the test isn't for a while, you should be going through the practice test periodically to make sure that you still know what you're doing. Understood? All right. Now that we've got all that administrative stuff out of the way, about 3.5 minutes later, let's talk about other types of equations. So the first type would be polynomial. So a polynomial looks like this. Oops.
Good morning, teachers. Just wanted to remind everyone to check that email from the student one more time about TSI testing.
I did.
Again today, so you got an email this weekend.
So there's your polynomial right there. Basically, you just have to remember that you've got whole number coefficients on x, or excuse me, real coefficients on x and whole number powers of x. Basically, when we did quadratics, we had several different methods to solve them. For now, if we're dealing with higher power stuff, one of the only tricks that you can use to solve it would be to factor. So, let's solve some. Let's say I have 3x to the 4th equals 27x squared. If you want to factor something, what do you have to do first? This is one of the most important things. Got to set it equal to 0. That's right. So, how would I accomplish that? You certainly could. I'm going to subtract the other one though. The only reason for that would be I like to have my leading coefficient positive if at all possible. I tend to mess up less. What would your next step be at this point? You could factor out a 3 for sure. You can do better than that though. You can take out a 3x squared. Always your first goal when you're trying to factor is to try to take out a common factor. And so in this case, that would be 3x squared. Now if I take out 3x squared, what will be left on the inside? All right, so x squared minus 9. How does x squared minus 9 factor? And x plus 3, right. And I still have my 3x squared. So what are my solutions here? For sure. There's one more. 0. That comes from the 3x squared. Because basically you're saying, okay, x plus 3 equals 0, so x would have to be negative 3. X minus 3 equals 0, so x would have to be positive 3. And if 3x squared equals 0, then x would have to be 0. Whenever there's a variable on the outside, like this, that means that you're going to get x equals 0 as one of your answers. Now, if it were just 3 out there, if the other x weren't there, if it were just that, 3 itself is never equal to 0, so you wouldn't have a solution for that. Does that make sense? You got to have the variable out there to get x equals 0. All right. Now, let's solve this one. Hello? Yeah, what would that accomplish? Why would I need to do that? Yeah, you got to get it equal to 0 if you're going to factor it. So if I subtract 4x and add 4 to both sides, wait a minute. That's a plus. I apologize for my failure. I was looking at it and I was like, that's not going to factor. All right. So we good after my mess up there? All right. So anyway, this is x cubed plus x squared minus 4x minus 4 equals 0. Nicely done. Factor by grouping. I taught you a thing or two, either that or you remember that from algebra. I'd like to think I taught it to you, though. All right, so what can I take out of this first group? X squared. So if I take out x squared, what am I going to be left with? X plus 1. Nicely done with the plus 1. Because if you take x squared out of x squared, there's a 1 left. If you take the whole thing, there's always a 1 left. Because it's like division. X squared divided by x squared is 1. What about the second piece? Take out a negative 4. And you have to take out a negative 4 because you want this to match. And since both of these are positive and both of these are negative, then you need to make sure you take out a negative to make this x plus 1 here equals 0. Then what? Say that again, I didn't catch it. All right, so I've got x squared minus 4, and then x plus 1. Go ahead. And now that it's broken all the way down, you can see what your solutions would be. What would they be? All right, so 2 negative, whoa. Negative 2 and negative 1. And by the way, you could put, you remember on the last one I wrote x equals this, x equals that, so on and so forth? You can write it either way. Fair enough? All right. This is just written as a solution set, whereas this one back here is just written as a bunch of x equals this, x equals that. All right. So, do you feel like you need another factoring by grouping example? All right, then we'll go ahead and forego that. And we'll go ahead to the next piece, which is something I haven't discussed with you before, so it'll be something new. Try not to die. I just said that on video. Oh, we're at 13 and a half minutes. We better stop.